Hey everyone, welcome back. In today's video, we are diving into the single responsibility principle, often abbreviated as SRP, and how it applies in C++. This is one of the 5 solid principles of object-oriented design, and it's an incredibly important one to get right when you are building scalable, maintainable software. Let's start with the basics. What is the single responsibility principle? The formal definition says a class should have only one reason to change. In simpler terms, that means every class or module in your code should only do one thing, and it should do that one thing well. Now, in C++, this can be tricky. It's easy to create big classes that do a little bit of everything, especially when you are in a rush or building prototypes. But over time, those classes become harder to test, harder to maintain, and much more likely to break when you change them. Let's walk through a simple example to see what a violation of SRP looks like. Here we have a class called report. It can generate the report, save it to disk, and also send it over the network. On the surface, this might seem convenient. Everything is in one place. But this class is violating the single responsibility principle. Why? Because it has multiple reasons to change. If the format of the report changes, that affects generate report. If the file system changes, or we switch to using a database, that affects save to file. And if the network protocol changes, that breaks send over network. Each of these behaviors represent a separate responsibility. Let's refactor this class to follow SRP more closely. We will spit out each concern into its own class. Now we have 3 small classes. Report is only responsible for generating the report content. File saver handles saving data to disk. Network sender takes care of communication. Each class has a single reason to change, and that's exactly what SRP is about. This is also a lot easier to test. For example, if we want to write a unit test for report generation, we don't have to worry about mocking file input-output or network calls. So why does this matter in real-world C++ code? Let's think about the types of bugs we run into when violating SRP. One classic issue is that a change in one area unexpectedly breaks another. You update the file saving logic to handle UTF-8 properly, and suddenly the report generation stops working. Why? Maybe a shared buffer changed format. This kind of coupling is what SRP is designed to avoid. It also matters for team collaboration. If one developer is working on the file saving logic and another is modifying the report format, and both changes affect the same class, you are going to have merge conflicts and poor cohesion. With SRP compliant design, multiple people can work independently with minimal interference. Now I want to be clear. SRP is a guideline, not a hard rule. You don't need to obsessively split everything into 1,000 classes. But when you find a class doing several unrelated things, it's a strong signal that it's time to refactor. Let's look at another example, this time from a more practical C++ domain. Logging. Here is a simple logger class that writes messages to a log file and also supports different log levels. Seems okay, right? But what happens when we want to add new output options, like logging to the console or a remote server? Or maybe we want to change the formatting of the log entries. Each of these changes affect the same class. So again, we are breaking SRP. Here is how we might apply SRP to this. Now the responsibilities are clearly separated. Log formatter decides how the messages look. File writer decides where the message goes. Logger coordinates the two. Want to add console output? Just create a console writer. Want JSON formatting? Swap in a new formatter. The core logger class doesn't change. That's the power of SRP. It makes your code modular, testable, and open to extension, but close to modification. That's also touching on the open-closed principle, which we already covered in a video. Now, some of you might be thinking, doesn't this create a ton of small classes? Isn't that over-engineering? Great question. And the answer is, it depends. If your project is small, maybe 1 or 2 classes doing multiple things is fine for now. But if your application is expected to grow, or you are working with a team, or you are doing unit testing, then SRP starts paying off really quickly. In C++ especially, this helps you reduce header dependencies, minimize rebuild times, and prevent fragile base class problems. So it's not just a design philosophy. It has real tangible benefits in C++ development. To wrap up, the single responsibility principle says a class should have only one reason to change. In C++, this helps you create modular, reusable, and maintainable code. It improves testability and reduces unexpected side effects. And it makes working in teams much more manageable. Start looking at your classes with these lenses. What are all the reasons this class might need to change? If the list has more than one item, it's time to refactor. Alright, that's it for today's episode on SRP. Thanks for watching, and if you found this helpful, don't forget to like, subscribe, and check out the playlist on the screen. See you in the next one.